In this video, I'm going to show you how the 3DS authentication works in ultralight CE tags. So what I have here is a Arduino Uno card connected to a RFID reader writer based on PN532 chip. And if you want to use the MIFAR ultralight C, you have to have the PN532, not the MFRC522 RFID reader. And before you buy, there are many RFID reader writers based on PN532, but some of them do not recognize MIFAR ultralight C. What I have got here is the one that's manufactured by the ADA Fruit Industries, and this works very well with ultralight C. So if you want to try ultralight C, I would suggest you to use this board. So as I said in my previous videos, the MIFAR ultralight C type of cards are not available that much in internet. So if you're interested to buy, you can go to the website called Rapid NFC, and I have bought around 10 cards from this website. They're not that expensive, and these are very transparent type of tags. And if you want to buy the shield, the RFID reader, you can buy from eBay. So as you can see here, this is RFID reader writer based on PN532, and this is from ADA Fruit Industries, and you can buy this easily from eBay. And to use this with Arduino, you need a library, and ADA Fruit have provided a library which you can download from this website. This library allows you to read and write the pages. There is no inbuilt function to authenticate the MIFAR ultralight C. However, I have written a function. Probably in future videos I might show you how to write such functions, but you still need the base library, which allows you to read and write the various pages of ULC tags. If you want to use the 3DS encryption and decryption, you can download the library from this website. So this is good. I have tried, and this library does its job, and this is available as as open source with the GPL3 licenses, and you have to be just to go through licenses before you use it. And if you want to do this in a .NET platform, you can use the DDS library from Microsoft. And what I'm going to show in this video is based on the DDS class, and I have not used this Arduino 3DS library. So there are good examples on how to use 3DS, and if you have done a .NET programming before, it's easy for you to understand. Otherwise, just look for my later videos. I might have one video explaining how to use the DDS. So I have written a small program in .NET, and that looks like this. So this program connects to this Arduino using the USB, the COM port, and I'm going to show you how this 3DS authentication works. And I'm also going to use the ultralight C tags, which I got it from Rapid NFC. These are very transparent tags, as you can see here. Okay, so first let me explain you how authentication works. Then I'm going to explain in detail how everything is put together. So the first thing is I'm going to connect to my Arduino, which is connected to the COM port 4 in this case. So I'm going to select the card, and here this shows the UID of the card, and by default this is a new card. So all new cards are based on a predefined keys, which which is called as the break me if you can. So I'm going to authenticate. So I've got two steps here. The first, authenticate. So I'm going to get, basically I'm doing a challenge, and you get some keys. I'm going to explain that soon. So next thing, step 2, if you get some result here, that means authentication successful. So if you look at the documentation of MIFARE Ultralight C, you can see that so the keys now are stored in page 42 to 47, and this key consists of 16 bytes altogether, and what you see here is the hex equivalent of the default key, which is called the break me if you can. So if you want to set or change the key, you have to write the key into these 4 pages. So the documentation says this is possible by using the 4 separate write commands, and each command you have to save the 4 bytes. So back in my program, so I'm going to try this again. So what we just saw is we are able to authenticate using the default key. So I'm going to take out this and select the tag again. So I'm going to show you how exactly that authentication works. All authentication process starts from the Arduino, starting with a challenge command. So when I click on this auth step 1, so I'll be sending the first command, like a challenge command, to the ULC. So when I click, what ULC has done is it has generated a key which is RNDB, which I have explained in previous videos, and this is encrypted random number produced by the tag. So this is been decrypted using the .NET 3ds library. So after decrypting this, you got the RNDB as this, and from this you can compute the RNDB dash, which is shifting this left. So as you can see, the EE is here, which has come to the right side. At the same time, Arduino will produce a random key which is called RNDA, and RNDA concatenated with RNDB dash, which is encrypted. What you see here is the outcome of encrypting, and this encryption is done using the .NET the 3ds library. So what has happened so far is the decryption and encryption has happened so far, and this encrypted key will be sent to the MIFARE Ultralight C. So when I click Alt 2, this whole thing is sent to the ULC, and the ULC is going to respond with either an error message, or it's going to respond with some data which you're going to see now. So as you can see here, the ULC has responded with an encrypted version of RNDA dash. So from RNDA dash, after a decrypt, you will get this RNDA, which matches the RNDA produced by in the first step. Okay, so when these two matches, so we are sure that the authentication is successful. Then after authentication, you can start reading and writing any protected pages. So I'm going to show you how to change the password, and you have to be careful. So because it's a 16 byte number you have to remember, otherwise it's very difficult to know what the password is, because you can never read out the value of the password. So I'm going to change, so I'm going to take the card again and put it back. So let me change the password to A1, say A2, A3, A4, A5, A6. So what you can see here is, have the screen layout matches the way the data is stored in the ULC. So the first page data here, the second page, third and the fourth page. The documentation speaks about having two keys called key 1 and key 2. So the A1 series is considered as key 1, and the A2 series as considered as key 2. Okay. Now here, if I click on the right case, I'm just issuing, sending everything to my Arduino. Arduino in turn will save, or will use the 4 write commands to save in 4 different pages. So write. So you got a message called successful keys. That's it. If you try to authenticate, or before that, so whenever you change the key, you must start the reading again. So take the card and select again. Okay, if you try to authenticate, let me see that if you try to authenticate with, so if I hit this factory button, I get all the factory keys here. Try to make a challenge. The ULC send you some key, and we are trying to decrypt this with our factory key, and we're going to send it back to this ULC. And when you get this as 000, that shows that authentication has failed. So in order to do the proper authentication, we know the key. And also keep in mind, whenever the authentication fails, you must always select the card again. So click on the select. So I'm going to change this the password keys to the A1 series, and we'll try again. So as you can see here, I've entered the keys as A1 to A8 and B1 to B8, and I'm going to issue this challenge. So the first command doesn't depend on any key. The ULC just returns you with the random key, and everything starts now when you decrypt it using this key. I'm using this key and send it back. You got this number, and as you can see, RNDA matches this. So it's very simple to use the 3DS authentication keys authentication with the ULC.